Okay, and our second assessment over the composite functions. Okay, I'm going to pull out a piece of scratch paper here. And we have two functions, f and g. Okay, first is adding. That's easy. You just make two parentheses for the two functions. This is the f, this is the g. The f is 5x to the power of 2 minus 1, and the g is 8x minus 3. So to simplify, it's a three-step thought process. There's a power, but it's just to the x. There's no multiplication. There's a plus sign, okay? So collect like terms. So x is second, we got 5. X, we got 8. And then -1, -3 is -4. Then I insert -4 into the expression for x. Second plus 8. I got 44. Okay. Next, now we have a subtraction. Okay. So f, again, 5x to the power of 2 minus 1. And then g, 8x minus 3. Okay, we have a power just to the x. We don't have anything we need to distribute, no rainbows, no multiplication. Now, before I collect like terms, we're going to make that plus, and the 8 goes negative, and the 3 goes positive. You got to change them both. Anything in that second function, you got to change. So, collect like terms. So, x is second, we have 5, -8, -1, and positive 3 makes 2. Okay. So a couple differences. That's now a -8, and I have a different constant. So now I put -3 into the function. $71. Okay, next we have a division. Division, don't do the 1, 2, 3. Just set your f in the numerator, meaning the top, and your g in the denominator, meaning the bottom, and that's all I want to see. Now here, you plug the 2 into the numerator and denominator separately. Don't try to do it all at once. You get a bunch of messed up things. So I get 19 in the numerator, and 8 times 2 minus 3, that'd be 16 minus 3, that's 13. Leave it in as an improper fraction. You can't reduce it. I don't want it as 1 6/13. Okay, I don't want you trying to play that game. Okay, now this does not mean multiply. This means I need to construct an input. I'm still going to do my 1, 2, 3, but first I got to get some things situated. I write my f function down, which is 5x to the power of 2 minus 1. Now, you need to replace that x. And the second power is going here, because that entire g is going to be to the second power, and that's 8x minus 3. Now, we cannot get rid of step 1, because that 2 does not belong to just the x. It belongs to that whole binomial. So to deal with that, you drop your 5, make a new parentheses, and we're not going to put a second power in there. We're going to minus 1. Now what happens in here, we're going to end up with x second, x, and then something else. Now to find out what it is, we're going to have to go somewhere and find what 8x minus 3 times 8x minus 3 is with the 1, 2 process. So 8x multiplied by 8x, and then multiplied by -3. By 8x. So that's 64x to the second power, -24x, -24x, and 9. So what do I have? I have 64x to the second powers. That would give me -48x's and 9. So now I can put 64, -48, and 9. Step 2 cannot be crossed out because I need to distribute the 5 to the trinomial. So 5 times 64. That's 320x to the second power. 5 times negative 48x would be negative 240x. You can put plus, negative, or minus. It don't matter. 5 times 9 is 45. And then don't forget you got the minus 1. Okay, now collect like terms. You always do step 3. 320, negative 240, and then 45 minus 1 is 44. Okay, and that's your answer. So again, you write your f, put the g in for it. That second power has got to be dealt with. So 5 parentheses minus 1, then you duplicate that out twice, distribute the 5, and go from there. Okay, now I'm inserting the 2. Okay, I got 844. Okay, next one. Start with your g. G is 8x minus 3. And replace your x with the f. And again, you're going to do the 1, 2, 3 down here. First, you got to get your input. Okay, so that's going to be 5x to the second power minus 1. Now, this one we can get rid of step 1 because the power is on the inside just to the x. Step 2 you got to distribute the 8. So that's 40x to the second minus 8 and then minus 3. Now collect like terms. Okay, x seconds, we got 40. You don't have any x's, and then negative 11. Okay, then insert your negative 5. $989. Okay, it's okay. All right. Given that this is the input function, find the 2 separate functions that can be composed to make this. So first, let's parenthesize the inside part of that. And x minus 3 is my g, okay, since the g is put in. Now for the f, I've got 4 square root. Instead of x minus 3, you're just going to replace that with just x, and then plus 5. Okay, find the inverse of the equation. The inverse is when I have to switch the x and the y, and then I need to get that y variable by itself. Okay, I don't want to see y again. Once you write it here, that's all you do. Now you need to first minus 10. So now I have x minus 10 equals 2y to the second. Then I undo the multiplication of 2. Okay. Now, I don't know what number's over here, so I just keep it x minus 10 over 2. I'm just going to put that down here. Now, with the power, we just put a root over it with a 2 in the index. Or if you left the index empty, that'd be okay, because that technically automatically would be a square root. Okay, now the next one, cross out A and B, please. Don't need you doing that. Buy a refrigerator. There's a 7% tax and a $75 delivery fee. So I'm composing equations. So I don't know how much this fridge cost. So first I take the dollar amount. Now delivery fee is added, okay? And the percent would be multiplied, okay? You want to multiply in the front, add, subtract. Okay, so $75 delivery fee. Now, to do a percent growth, tax is growth, okay? You're not going to use a power because it only happens once, but yeah. Okay, you're going to add that 7%. Gives me 107%, and then divide it by 100, and that's 1.07, okay? Okay, you've done the hard work. Now they want $75 delivery fee applied first, so I parenthesize that part of the expression. Here they want the percent first, so I parenthesize the multiplication portion. And now I can put 1,300 in for my x's using the parentheses. Remember to print the size where it needs to be. So that's $1,471.25. Okay. And how about here? $1,466. Okay, they're always slightly different. That's all I need to see. Okay.